Hi everybody, my name is Doug Barr and it's my pleasure to welcome you to the St. Helena Forum for Innovation and Creativity. The Forum is an educational nonprofit with a mission to inform, entertain, and occasionally inspire by presenting artistic performances and exchanges of creative and innovative thinking on a wide variety of humanities-based subjects. Today's forum conversation will focus on an object that in early September of 2017, traveling at 58,900 miles an hour, entered our solar system from interstellar space. By September 9th, it had reached its perihelion, which is the point at which its trajectory passed closest to the sun. And then by October 7th, the visitor raced in the direction of the constellation Pegasus, away from our solar system and back into the silent darkness of deep space. What was this interstellar object? The first ever discovered in our solar system. Well, lots of ideas have been suggested by astrophysicists from around the world, but our guest today believes that his somewhat controversial hypothesis is supported by the clearest and most compelling evidence. And he's here at the forum to share that evidence with us. Dr. Avi Loeb is the Frank B. Baird Jr. Professor of Science at Harvard University. He received a PhD in physics from the Hebrew University of Jerusalem when he was only 24 years old. He led the first international project supported by the Strategic Defense Initiative and was subsequently a long-term member of the Institute for Advanced Study at Princeton. Loeb has written 8 books, including most recently Extraterrestrial, and over 800 papers on a wide range of topics, including black holes, the first stars, the search for extraterrestrial life, and the future of the universe. Loeb is the director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics, and also serves as the head of the Galileo Project. He's been the longest-serving chair of Harvard's Department of Astronomy and the founding director of Harvard's Black Hole Initiative. He's an elected fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. Loeb is a former member of the President's Council of Advisors on Science and Technology at the White House and a former chairman of the Board on Physics and Astronomy of the National Academies. He also chairs the advisory committee for the Breakthrough Starshot initiative. In 2012, Time magazine selected Dr. Loeb as one of the 25 most influential people in space, and in 2020, Loeb was selected as among the 14 most inspiring Israelis of the last decade. Everyone, please welcome Dr. Avi Loeb. All right, well, thank you, Avi, so much for joining us today. I really appreciate you being here. Let me start by telling you that in anticipation of this, we had a wonderful, crisp, clear night about a week and a half ago here in Northern California, and I took advantage of that and went out on my deck, and I looked up at the stars and felt the immediate wave of awe and humility at how minuscule I am in the face of all those things. And then I got cold and I went back inside. And I suspect that that's kind of the extent of most people's relationship with the night sky. And so I'd like you to sort of, as we raise the curtain on our conversation, Avi, I'd like to ask you to, if you don't mind, would you just help set the scene? Tell us how old the universe is. Tell us how many sun-like stars supporting potentially life-friendly planets might exist in the Milky Way. How many life-sustaining planets there are, or observable stars, how many in the volume of the universe. Give us a sense of place so that we know the context in which we're going to discuss the rest of the things this afternoon.
Thank you, Doug, and it's a great pleasure to join you. Well, we are born into this world like actors being put on a stage, and we tend to think that the play is about us. And I can sort of understand that because when my daughters were young, they thought the world centers on them. It's a very natural inclination based on the fact that most of the data, most of the information we receive is close to us. So we think, well, it's centered on us. And we apply that also to the universe at large. And that's what the ancient Greek philosopher Aristotle argued. And people believed him for 1,000 years, that we are at the center of the world because it flattered their ego. But it wasn't just that. Even when evidence came along that indicated that we might not be at the center because the earth moves around the sun, and Galileo Galilei said to the philosophers, please look through my telescope, it might convince you otherwise, they said, no, we know the answer, we are at the center of the world, and we don't want to look through your telescope. They put him in house arrest, and today they would have canceled him on social media. Now, if you were to ask these philosophers to design a rocket that will reach Mars, they would get the trajectory of the rocket wrong, because they would assume that Mars moves around the Earth. That was their worldview. So my point is, it's not a philosophical question. It's a practical question. We need to have a correct view of reality in order to act responsibly. But if we insist that we know the answer in advance, before looking through a telescope, before collecting evidence that will teach us what the reality is, then we might be living in a virtual reality. Now, there is an infinite number of virtual realities that we can live in. And in fact, the idea of the metaverse is that you can put goggles on your head and visit the virtual reality that flatters your ego. And that could be a virtual reality in which you are at the center of the universe. Now, what makes it different from the actual reality is that it's not shared by everyone. And I think my duty as a physicist, as a scientist, is to deal with the actual reality and be guided by data and not by our prejudice. That's the biggest legacy that Galileo Galilei gave us. And using that approach of learning about the universe, not based on philosophical reasoning, but based on evidence, we learned that we are not at the center of the stage, that in fact, the universe is not centered on us. We are not at the center of the solar system. The solar system is not the center of the Milky Way galaxy. And the Milky Way galaxy is one of a trillion galaxies in the observable volume of the universe. And those galaxies are receding away from each other. So in fact, the universe is expanding. And if we go back in time, there was a point in time when all the matter had an infinite density, because you go back in time, then the galaxies were approaching each other. And there was a point in time where matter had an infinite density, and that is called the Big Bang. That's a point in time that when the universe as we know it started. And Einstein had a problem with that, because philosophically speaking, it's problematic. We don't know what happened before that. And one of my thoughts these days is that, it's possible that our universe was created in the laboratory of an advanced civilization. That is not ruled out. You can imagine that if we had a good understanding of how to unify quantum mechanics and gravity, at some point in our future, we might produce a baby universe in our laboratory. We don't have that knowledge. All we have is Einstein's theory of gravity, and that doesn't include quantum mechanics in it. And therefore, we cannot figure out what happened at the Big Bang or before that, because Einstein's theory breaks down. But one thing we know, since the Big Bang, there were 13.8 billion years that elapsed, and we just came at the end. So not only we are not at the center of the stage, but it's clear that the play is not about us, because the play has been going on for 13.8 billion years. And the universe is huge. And there are about 1 trillion galaxies the size of the Milky Way. And if you count how many stars they have, it's 10 to the power 21. So there are more stars than the number of grains of sand on all beaches on Earth. Okay, just think about it. And then we know by now from the Kepler satellite that a fair fraction of all the sun-like stars, about a half or a third, has a planet the size of the Earth, roughly at the same separation. So not only we are not at the center of the stage, we're also not privileged. It's very common to have an Earth-Sun system. And guess what? Most of the sun-like stars formed billions of years before the sun. So if you just adopt modesty, all of that teaches us modesty. We are not privileged, even though we tend to think that we are privileged. When I took my daughters to the kindergarten, they realized there are other kids out there, and some of them are smarter than they are, and they are not privileged. So if we just adopt a sense of modesty, given all of these facts, then we might say, okay, well, we are sending equipment to space. Someone else might have sent equipment to space 1 billion years before us. And during 1 billion years, such equipment can reach everywhere in the Milky Way galaxy using the current rocket technology that we use. And so my point is, we are still about to have a new revolution. So there was the Copernican revolution that implied that we are not at the center of the stage, we are not at the center of the universe. But the next big revolution would be that we are not the most intelligent species that existed since the Big Bang. So another way to phrase it is, Albert Einstein was not the smartest scientist that ever came to exist since the Big Bang over the past 13.8 billion years. It's very likely that there is someone smarter than Albert Einstein out there.
Great context that you've set for the rest of this conversation. So thank you for that. Well, let's go back and talk about September and October of 2017. And that was when we were visited by the first interstellar object ever detected in our solar system. By the time it had acquired its name, which ended up being called Omula Mua, which is Hawaiian for scout or a messenger from afar arriving first, it was already 20 million miles away from Earth. So this thing came in, it went through our solar system, and it swept out. Can you tell us what the trajectory was for it coming in and the trajectory on its way out? And what was the course and kind of a timeline over that very short period that it was here? What was the course it took? What was the perihelion, and what planets did it go by before it scooted out of here?
Yeah, just to put things in context, about 70 years ago, Enrico Fermi had lunch at Los Alamos with a group of friends, colleagues, and they were talking about extraterrestrial civilizations. And he said, well, it's likely that they exist out there, but where is everybody? He said. Now, this is very presumptuous because he's sitting in Los Alamos and expecting them to show up. But, you know, the recorded part of human history is only 10,000 years old, and that's 1/1,000,000th of the age of the universe. Moreover, you know, it's just like sitting at home and saying nobody is knocking on my door, therefore I don't have neighbors. Well, you have to look through your windows, and better with a telescope. And you know, he was behaving just like a fisherman, you know, looking at the ocean from the beach and saying, where are all the fish? I don't see any. Well, you have to use a fishing net. And, you know, nowadays we have instruments that would allow us to detect such things. But until a decade ago, there was no survey telescope able to find an object the size of a football field that passes within the orbit of the Earth around the sun from the reflected sunlight, an object that comes from outside the solar system. That's why such an object was never discovered. And then in 2017, this observatory, Pan-STARRS, which came to exist because Congress tasked NASA to find 90% of all objects bigger than the size of a football field, bigger than 140 meters, that may have a chance of colliding with Earth. So the Pan-STARRS Observatory was constructed in Hawaii, in Maui, on Mount Haleakala, and was looking for objects this size. And then most of them, or all of them, were expected to be coming from within the solar system. And then this object showed up, and it was clearly not bound to the sun. It was moving too fast. And it was the first object from outside the solar system that was spotted near Earth. But it's definitely not the first that arrived to the solar system. It's just the first that we spotted, okay? Just to illustrate the fact that we really, if we want to discover wonderful things, we need to look for them, okay? And it's not enough to say, you know, extraordinary claims require extraordinary evidence. You know, getting the extraordinary evidence requires extraordinary funding. We sort of know that to discover gravitational waves, the National Science Foundation had to invest $1.1 billion in the LIGO experiment. Okay, so without designing an observing system or telescope, we would not, without having a fishing net, we would not catch any fish. And this was the first fish from outside the solar system that was caught, and you would expect it to be typical. You would think, oh, it's just like the rocks that we have seen before in the solar system, like the comets or the asteroid. Well, to our surprise, it was not. Actually, I wrote a paper a decade earlier saying that pan-STARRS would not discover any rocks based on what we know about the solar system, because the number of such rocks that are ejected into interstellar space as a result of a passing star would be quite small. And the discovery was intriguing, therefore, for me. But the astronomers thought that those that discovered it must be a comet. A comet is a rock covered with ice, and when it gets close to the sun, the ice evaporates, and then you get a cometary tail of dust and gas around it. There was nothing like it. This object was definitely not a comet of the type that we've seen before. So then people said, okay, well, maybe it's a rock, a bare rock without any ice on it. But then as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. And that meant a very extreme shape, most likely pancake-like, based on the reflection of sunlight over time. And then the object was pushed away from the sun by a force, a mysterious force that could not be as a result of the rocket effect from evaporating gases. So the question is, what triggered that push? And the only thing that came to my mind is the reflection of sunlight. And for that, the object had to be very thin. And nature doesn't make objects that look like a sail that are pushed by reflecting sunlight. But in September 2020, the same observatory, pan-STARRS, discovered another object that shared the same qualities, that was pushed away from the sun by reflecting sunlight, no cometary tail. It was given the name 2020 SO, and then it was realized that it came from Earth. It was actually a rocket booster from a launch that of a lunar lander mission by NASA. And we know that it had very thin walls because we produced it. The question is, who produced Omula Mua?
Right. So let me just back up a little bit. Can you just tell me what the evidence was that pan-STARRS came up with? It's photographic evidence. But there wasn't much because it was already on its way out. It was already millions of miles away. So what exactly did pan-STARRS tell of the story? That was sort of a dot of light going past, or did they have more evidence than that? And then that evidence is how you and your colleagues were able to extrapolate size and shape and scale. It was spinning speed through our solar system. Is that all right?
No, we don't have an image of this object. If we had a photograph, we could tell its nature. And in fact, they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words. The number of words in my book, Extraterrestrial. I wouldn't need to write the book if we had an image. All we saw is a point of light from the reflection of sunlight by this object. And as the object was tumbling, the amount of light changed by a factor of 10. So what pan-STARRS noticed is the trajectory of this object, okay? And that implied that it's not bound to the sun. It moved too fast on the sky. We can infer from the orbit the speed of the object, and that implied that it's interstellar. Okay, that was the first important result from pan-STARRS. And then, of course, other telescopes were looking at it and trying to gain more insight about the nature of this object. But basically, we could not tell what it's made of. We could not tell directly by imaging its size. The size was inferred from the amount of sunlight reflected by it, assuming some reflectance. So it was of the order of the size of a football field. We don't know exactly how big it is. It could have been 10 times smaller than a football field if it reflected like a mirror. And so all we know is that an object of that size, we can infer from the variation of light as it was tumbling, the characteristic shape that it had, which must have been flat. And then the trajectory exhibited an excess push. It was not only the force of gravity from the sun that shaped the orbit.
That was the deviation that seems to be really important through all of this. Initially, the press picked up a picture that was cigar shaped, and that sort of rode along. And still, when if you type in Oumuamua on the internet, you're going to probably get that picture, but your vision of what it was completely different. So with the scientific method being, it's observation, measurement, experimentation, formulation, modification, and testing of hypotheses against the evidence. And so you're saying it wasn't cigar shaped, that it was theoretically flat and thin, and the others are saying that it was cigar shaped. Where
No, it's not. It's not the others are saying. It's actually the people who analyzed the data of the variation of light as this object was tumbling concluded that it's most likely flat at the 90% confidence level. And if you imagine, it's just an artist. An artist argued that based on the fact that the light varies by a factor of 10, it's 10 times longer than it is wide projected on the sky. Okay. Now imagine a piece of paper tumbling in the wind. When you look at the piece of paper sideways, it looks like a cigar, right? It could be 10 times longer than it is wide. That's what this artist put in the illustration. Something that is 10 times longer than wide, as if it was a cigar. But if it's a piece of paper, it's just because you are seeing it sideways that you see it looking like a cigar, but intrinsically it's a piece of paper, it's flat.
Right. I see. And that has hung on, unfortunately, because it doesn't really describe...
it's not unfortunately, because it has no scientific merit. Whatever that artist decided to illustrate, it's equivalent to someone that would make a tweet about the subject. It really doesn't matter how many people like one idea or another. It's all about evidence. It really doesn't matter what the philosophers did to Galileo. The Earth didn't stop moving around the sun as a result of what the philosophers said. And if there was an artist at the time that would show the sun moving around the Earth, who cares?
So the other major anomaly in the progress was LSR, which is a little bit complicated, local standard of rest. And you have a wonderful, in your book, an analogy that talks about a superhighway. It's a hard one, I think, for most of us to understand. But could you run through that? Because that combined with the deviation seems to be really evidence that's important.
Right. So Oumuamua had a number of anomalies. Another one of the anomalies is that it came from a special frame of reference, which is called the local standard of rest. It's the frame that you get to when you average over the random motions of the stars in the vicinity of the sun. You can think of it as the galactic parking lot, as sort of the average system that the galaxy has locally. Sort of like if you go to the center of a town or a city, you look at the parking lot, it doesn't move, okay? But then cars are moving relative to it, and the stars are moving relative to this frame of the galaxy locally, the local standard of rest. So the sun moves relative to it. But Oumuamua, this object, was nearly at rest in that frame. And only 1 in 1,000 stars is so much at rest as Oumuamua was in that frame. That was unusual, because if it came from one of the nearby stars, it should have inherited its motion. And if it came from a distant star, it would have moved even faster, because stars move relative to each other even faster as you go to larger distances. So it's really surprising that it was moving so slowly, or actually almost at rest within that frame of reference. And the question is why. It was just like a buoy sitting at rest on the surface of the ocean, and then the solar system, like a giant ship, bumped into it. And the relative motion of this object and us was simply due to the motion of the sun relative to the local standard of rest. So the question is why, and one can imagine a number of possible scenarios. If this object is artificial, it could be just a signpost, a road post that, there is an array of such objects distributed throughout interstellar space that help spacecraft navigate through interstellar space. So it gives the coordinates, so to speak, locally in the Milky Way galaxy, and that's one possibility. Another one is that it's a relay station for communication, that you have those placed, around in interstellar space, so that you don't need to broadcast very loud in order to reach far away. And they just, an extraterrestrial technological civilization just placed those relay stations. But we don't really know what the nature of Omula Mua was. And my colleagues argued it must be natural. So then there were 4 suggestions for a natural origin, and all of them contemplated something we've never seen before. Okay.
Before you get into breaking those down, which I definitely want to do, can we just take a small detour, and can you tell us a little bit about your background, how you ended up in astrophysics? I know you were born on a farm in Israel. Can you give us a little bit of background, and then we'll go back to those 4 different ideas, and then very well define exactly what your idea is and how some of this other information, the factual evidence, actually plays into your idea very, very well. So tell me about Israel, about your family and your parents.
Right. So my childhood pretty much shaped the way I do my science nowadays, because the most vivid memory I have from my childhood was sitting at dinner and asking a difficult question, and the adults in the room would either pretend that they know the answer, even though it was evident that they didn't know it, or they would dismiss the question if they had no idea how to address it. And I thought that by becoming a scientist, I can maintain my childhood curiosity, and I wouldn't be surrounded by these adults in the room. But to my surprise, in academia, very often you find experts that want to use their past knowledge to explain anything that comes along. So if an anomalous object shows up, and these experts studied rocks throughout their career, they would try to argue that this object is a rock of the type that they are used to. They would not say it's exciting, let's get more data on it. Rather, they would say what my colleague said after a lecture at Harvard on Omula Mua. He said, when we came out of the auditorium, he said, Omula Mua is so weird, I wish it never existed. Now, why would he say that? Simply because it threatens his image as the expert who knows the answer in advance, who recognizes reality in its full glory and doesn't miss anything. Just like the philosophers during the days of Galileo, it was threatening to them to realize that they might be missing an important aspect of reality. So that's one connection to my childhood, but I wanted to mention 2 others. One is that I grew up on a farm, so I was connected to nature. So nature is more important to me than people. Every morning I jog at 5 a.m. in the company of birds, ducks, bunnies, and wild turkeys. And I enjoy nature a lot, and exploring space in a way is, for me, exploring nature unspoiled by humans. So I don't have any footprint on social media. I don't care how many likes I have. And I'm trying to figure out the reality that we live in, not the virtual reality that we want to believe that we live in, but the actual reality. I want to see the pimples on the face of reality rather than put some makeup that makes it much better looking. Okay. And of course, if you go to the metaverse, put goggles on your head, you might be living in a much nicer reality. But I want to feel both the pain of science that explores reality. And the pain, for example, is that you can't live on the surface of Mars for more than a few years because your body, will be damaged significantly by cosmic rays. That's a reality that Elon Musk or Jeff Bezos are not discussing, the health hazards from living on the surface of Mars unprotected. But this is the pain of science, okay, the actual reality we live in. But there is also the pleasure of science that, you can live a long life here on Earth, and you can put goggles on your head that will give you pleasure by believing in things that do not exist. I mean, that is physics. The laws of physics allow that. But I, for example, do not like science fiction. So Jeff Bezos at a forum in the Washington National Cathedral on the 10th of November, 2021, he said that he was inspired to invest in space tourism as a result of being inspired by Star Trek. And I was sitting next to Avril Haines, the director of national intelligence. I told her, I never liked Star Trek because the storyline violates the laws of physics. And it always bothered me as a scientist. It makes no sense. I cannot enjoy it. So then I wrote about it in an essay that was published in The Hill. And then the same day I heard from William Shatner, who played Captain Kirk on USS Enterprise, invited me for an interview. And I told him, William, you are the one that would appreciate my point, because you were playing for many years in Star Trek, a main character, and about traveling in space. And then half a year ago, you went actually on a craft that was designed by Jeff Bezos. He went to space for the first time in real life, in the actual reality. And you would appreciate the fact that the actual reality of going to space must be very different from the virtual reality of Star Trek. And he agreed with me. Okay, so that's the other thing. So the other thing is that I really like to see the pimples on the face of nature. I want to see it the way it is. But the final thing that I wanted to say from my childhood, is that I grew up on a farm, and therefore I'm not very influenced by what other people say. I pretty much developed an independent way of thinking about things, and I really admire kids because they want to figure it out for themselves. And they are not attached to any baggage. They are not guided by their ego. They just want to figure out the world because it's new to them, and that's the spirit that I really admire.
Well, your mother, in your book, you talk about your mother encouraging curiosity. She also, and the practical side of you obviously comes from your father, who was the farmer. There's nothing and nobody on the planet coming from Iowa that's more practical than a farmer. And so you get that from them. But also, I read that you had a deep love of philosophy that was imparted to you by your mother. Is that the case too?
Yeah, exactly. And philosophy was exciting for me because it addresses the most fundamental questions that we have. And I used to read philosophy books, driving a tractor to the hills of the village, and then I wanted to pursue it later on in life. But in Israel, there is obligatory service in the military, and I had to be drafted. And I preferred to go to a program that allowed me to focus on intellectual work rather than running in the fields. And the path for that was for me to engage in physics, which I was good in, but I wasn't really thinking about becoming a physicist until I was forced to. And then I was offered a postdoctoral fellowship at Princeton after finishing my PhD at age 24. And then I was offered a faculty position at Harvard. Again, because someone didn't want that position, the chance of tenure was very small. And then I was tenured. So at that point, I realized it was actually an arranged marriage to astrophysics, but I'm actually married to my true love because there are some fundamental questions, philosophical questions that we can address in the scientific method. And that's what makes me different from my colleagues. Even though I became the chair of the astronomy department, longest serving for 3 terms, 9 years, between 2011 and 2020 at Harvard University. And I still feel that I'm somewhat different, than, and in my view, we go through life very often with a lot of pressure to resemble other people. You see, if you look at on the beach, once again, this example of seashells, right? So each of them is born with different colors, different shape, but then the seashells rub against each other and eventually break up into indistinguishable pieces that make up the sand, that makes up the beach. And, we should try as much as possible to avoid that fate. And by the way, rubbing against each other is pretty much what happens on social media. So I think one is losing the authenticity that you are born with as a result of rubbing against other people and trying to be liked.
Right. I think that makes utter sense. I studied philosophy in college as well, and the whole point of it is to ask the big questions, and the point of science and what you're doing is to answer the big question. So it seems like it's pretty good melding of the two things together in your career. All right, let's go back to Omula Mua for the moment, and if you'll talk to me a little bit about the other possibilities before we get to yours that have been brought up. They were mostly safe explanations based upon meteors or asteroids that were talked about. One of them was, and you mentioned it in passing, which was the University of Arizona group came up. That hypothesis was that it's a nitrogen iceberg that might have snapped off of a Pluto-like planet. So there's one. Could you just tell us what the good and the bad of that is? Why that could be fitting the evidence, but why it doesn't quite fit the evidence, and how they got past it not fitting?
Well, let me explain the context first. So at first, after my paper suggested that maybe it's artificial, there was a group of experts, leaders in studies of rocks within the solar system, that came together and wrote a review paper in the prestigious Journal of Nature Astronomy saying, this object is natural, there is nothing really unusual about it, period. Okay, establishing that by authority. Okay, if that was right, then the rest of the story doesn't make any sense. Because what happened was that several months later, there was a team of mainstream astronomers who said, well, actually, this unusual property of excess push without cometary tail of Oumuamua needs to be explained. You can't just say it's a standard comet, because we should have seen something. Okay, and there were very tight limits being put by the Spitzer Space Telescope on any carbon-based molecules around this object. So then this group suggested, well, maybe it's a chunk of frozen hydrogen. So hydrogen is transparent, and when it evaporates, you won't see the cometary tail. We've never seen a chunk of frozen hydrogen in space. So the way to make it is not in a planetary system like the solar system. You have to make it in molecular clouds. We don't know if molecular clouds make chunks of frozen hydrogen, but this was hypothesized as something we've never seen before. And maybe there are these nurseries making these objects, one of which is Oumuamua, at a great abundance, larger abundance than rocks, because this is the first object that we saw. Now, after that proposal was made, we wrote a paper with a colleague of mine showing that hydrogen iceberg the size of a football field would get evaporated very quickly, within a few million years, throughout its journey in interstellar space. And therefore, there is a big challenge to this idea. Okay, so then there came another group and said, well, maybe it's a cloud of dust particles that are very loosely bound, sort of like a dust bunny that you find at home, and it behaves like a feather. It reflects sunlight and then getting pushed, 1,000 times less dense than air. Now, the problem with that is when it comes close to the sun, it will get heated by hundreds of degrees, and it will not maintain its integrity. It's very difficult to imagine something that is 100 times less dense than, imagine the steam that comes off a boiling pot of water. So just 100 times less dense than that, maintaining its integrity after getting heated by hundreds of degrees. So then came this team that you mentioned and said, well, maybe it's a chunk of frozen nitrogen, not hydrogen, but nitrogen from the surface of a planet like Pluto. So together with my student, we said, wait a minute, there is not enough nitrogen. So if you just take all the nitrogen on the surface of planets like Pluto, in the entire Milky Way galaxy, you can show that the mass budget does not allow enough chips to account for the abundance of objects inferred to be Oumuamua like, because the assumption is that they would move on random trajectories, so you can estimate how many of them you need per unit volume so that Oumuamua would be discovered by pan-stars, and then there is just not enough nitrogen. So we wrote that paper. Now, you might say, why are people suggesting all these things that we've never seen? We've never seen a nitrogen iceberg in the solar system, by the way. And how is it possible that the original group of experts, the authority in the field, came up with a definite conclusion that Oumuamua must be natural, and then other teams had to invent the hydrogen iceberg, the dust of the cloud of dust particles or the nitrogen iceberg. To me, it explains, why all of these proposals were made. People want to make it natural. It's our desire. That is the virtual reality that we want to live in, that it is a natural object. So the first group of experts declared it natural, just like the philosophers declared that the sun moves around the earth. They just say that. And everyone should be afraid of, arguing against it, because if you're a young person looking for a job, you have to worry about not being popular among the senior people that make up this group. That's the importance of authority. If you come in a herd that has enough political power, other people will hesitate whether to argue otherwise, okay? So that's the significance of a group of people coming together. There was this book written in the 1930s by 100 scientists against the theory of Einstein's special relativity, okay? And the title of this book was 100 Scientists against Einstein's theory of special relativity. And then Einstein was asked about it. They asked him, what do you think about it? There are 100 people arguing against you. And he said, well, if they had a good argument, you wouldn't need 100 of them. It's enough to have one. So the point is that people come together in order to establish authority. And it's clear that was the message of the first paper, because otherwise there wouldn't be a need for more papers to be published by independent people explaining why it should be natural by something that we've never seen before. And if you think about it, a caveman finding a cell phone would argue it's a rock of a type that I've never seen before, right? Because the caveman is used to playing with rocks. But I say it's the beginning of a learning experience. If the caveman is curious, like a kid, the caveman might press a button and notice that this unusual rock records his voice. And if he presses another button, it records his image. So then it will become clear that it's not a rock. But if the caveman would declare with confidence, even without looking, just saying, okay, this is a little more shiny than usual, let's throw it out. He would publish a paper in Nature Astronomy saying, or go back to the cave and tell his family, I just saw an unusual rock, that's it. Let's move on. Let's continue to hunt out there. Then, of course, it will be a self-fulfilling prophecy. So my point is, it's a circular argument to argue that extraordinary claims require extraordinary evidence, because that makes you lazy. It makes you not pursue extraordinary evidence. And to get extraordinary evidence, you need to invest resources. You need to invest extraordinary funds. And to invest those funds, you need to be curious. If you're not curious, you will never find anything unusual.
Thankfully, you know that because of your mother. So she made you curious from the get-go. So obviously these that started out with what's the easiest route here, that's sort of the Occam's razor route. The simplest is usually the correct. It doesn't really apply here because there were so much anomalous.
Exactly. If Occam razor was to apply, then you wouldn't need the nitrogen iceberg. You wouldn't need the hydrogen iceberg. These are not simple explanations. They are talking about things we've never seen before. My point is simple. Let's come close to the next Omula Mua and take a close-up photograph. We could easily tell if it's a nitrogen iceberg. I'm willing to bet that it's not a nitrogen iceberg, okay? But some people are very convinced and they celebrate it and say, okay, that must be the case. I say, okay, well, let's figure it out. I established a project called the Galileo Project. And one of the important tasks of this project is to design a space mission that will bring a camera within 1,000 kilometers of the next Omula Mua. It's just like going on a date and you like the person you dated, but that person is not around anymore. So you say, okay, well, I'll go on another date and find the next person that looks like it. So we want to date the next Omula Mua and bring a camera very close to it, 1,000 kilometers away, so that we can take a close-up photograph and tell what this object is all about. That's all I'm saying. And even that has a lot of people wishing us not to succeed. Basically, How is that scientific? How can people say, oh, this project is not worth pursuing? Like, this is the scientific method.
Yes, exactly. Well, there's room for imagination, obviously, in the scientific method. If it was just a rock, a dry asteroid, that was one thing. They moved beyond that, at least with the hydrogen and the nitrogen ideas. At least they were a little bit different, but we still haven't really had your idea defined. So let's go right to what you think Omula Mua might have been. You're not saying it was. You're saying it very likely could have been because of the evidence. You started with the evidence and then figured out what fit the evidence, as did the hydrogen and the nitrogen. But let's hear your thoughts on this, and then we'll go from there.
Right. So all I can say is that it could have been just a very thin foil or piece of matter. Now, just like 2020 SO, this object discovered in September 2020 that by the same telescope that exhibited excess push by reflecting sunlight with no cometary tail. It was thin not because it was a sail, not because it was supposed to be propelled by reflecting sunlight, but simply because it was constructed this way. And the purpose of that rocket booster was completely different from a sail. Okay, it was supposed to be part of this lunar lander mission. And then I think it's, so there are two possibilities for Omula Mua. One is that it's a defunct piece of equipment, or maybe even just the outside layer of something bigger that was torn apart and just moved through the solar system. And we noticed that it's unusual because it's thin, And the second possibility is that it's functional. So if it's functional, it could be collecting information about the habitable region of the solar system. It could be used for other purposes. We don't know. And my point is, it should just inspire us to look for more unusual objects. That's what the Galileo Project is about. And, the people that read my book came to the porch of my home over the summer in June and July. And within a few weeks, I received $2 million to my research funds at Harvard after they asked me questions. They were inspired by the book and asked questions about the message in the book. And it's clear that the public is very interested in this subject. But moreover, more importantly, the government is interested because on June 25th, the Director of National Intelligence, Avril Haines, who sat next to me in that event in November, she delivered a report to the US Congress suggesting there are objects whose nature the government cannot tell. It's not clear what they are. And obviously, we saw just the tip of the iceberg because there is a lot of classified data that we cannot see, the public cannot see. But people who saw it, like former CIA directors, Brennan and Woolsey, former President Barack Obama, former Director of National Intelligence John Ratcliffe, and Bill Nelson, the head of NASA, who saw some of the data as a senator, all argue that it's a serious matter, that the classified information indicates objects that cannot be explained easily as human-made, as being manufactured by our adversaries, as atmospheric phenomena. So all of this together basically inspired me to establish the Galileo Project. Given that I had the money, I could do it on my own. And by now we have more than 100 scientists engaged in the project. And we are planning to build the first telescope system on the roof of the Harvard College Observatory during the spring of 2022, and then make copies of it that we will distribute in many different locations. That would be the part that tries to collect more information about these unidentified aerial phenomena that the government talks about. And the second component of the Galileo Project is to find the next Omula Mua and send a camera that will come close to it. And it's quite obvious why we chose the name Galileo to this project. And if he were alive today, I would obviously would have invited him to be part of the project.
It's a very exciting project. I was going to get to that at the end, but we don't need to wait to the end for that because it's truly fantastic, and I want to make sure we talk about that, and maybe we'll circle back and talk about that a little bit more. Could you talk a little bit about light sails and the concept of how a light sail would work and how that might have been applicable to Omula Mua?
Right. So if you imagine a thin film of material, it can be pushed by reflecting light. Now, in principle, you can imagine propelling a spacecraft this way, just like a ship, a sailboat is being propelled by reflecting the wind from its sail. And in this case, you can think, in the case of a sailboat, it's the molecules that make up the air that bounce off the sail, and as a result give it the push. In the case of a light sail, it's the particles of light, photons, that bounce off the sail that give it a push. It's exactly the same physics, except particles of light move faster. They move at the speed of light. And so this idea was conceived about a century ago. It's nothing new, but the technology to use light sails is being worked on right now, and it hasn't been demonstrated for propulsion of spacecraft as of yet. But the key advantage of it is that you don't have to carry the fuel. So the type of spacecraft that we launched in the past were based on the rocket effect, where the craft carries a lot of fuel to start with and then throws the fuel backwards in the form of the jet that propels it forward. So you have to take a lot of mass with you to start with and then throw it backwards so that the little bit of payload on the top gets propelled to the right speed. And it's the same method by which jet planes are being propelled. They throw back the fuel that they have in them. I once went on a flight, and it was a long flight. I had time to estimate and how much fuel you need to throw back in order to propel the plane to the appropriate speed, and it works out. It's just the right one. So it's based simple physics, and so the advantage of the light sail is it doesn't need to carry any fuel because the light from behind it is being is pushing it.
Is that how the Yuri Milner project, the one that you started working on, Starshot initiative, are you still working with those guys, and is that going forward? And that was being propelled by light that you were going to use laser beams to shoot towards this to keep it moving. Is that all correct?
Yeah, well, so Yuri Milner came to my office at Harvard in 2015 and asked me to think about a concept that will bring a probe to the nearest star system within our lifetime, meaning within 2 decades. And the nearest star is 4 light years away. So in order to get there in 20 years, let's say, you need the spacecraft to move at 1/5 of the speed of light. And that is 1,000 times faster than chemical rockets. And the only method that came to my mind that can do it is a light sail, because in principle, you're pushing the craft with light, so you can reach 1/5 of the speed of light. And we came up with the concept of a very lightweight craft that weighs a few grams being pushed by a very powerful laser beam of 100 gigawatt for a few minutes across a distance that is 5 times the distance to the moon, and then it goes on a straight trajectory towards its destination. And that's the Starshot concept. And it's very challenging because there are several components here that are not demonstrated as of yet. The laser beam, making a powerful laser beam that is focused on the sail, and then designing the sail in terms of material and shape to be optimal. And then the communication between the sail and the Earth at 4 light years away, which is very challenging. So we have experimental teams working on these challenges at the moment. I cannot say that we demonstrated that it's feasible, but it's important to take the first steps in a long journey, because otherwise you would never make the journey.
Any steps, no journey, exactly. Your Proxima Centauri and Proxima b, you chose them for the location, obviously, that they were the nearest. Did you have any expectations that if you got there, what you would find? Had you thought about what might be there? Because it's a habitable zone, Proxima b, right?
Yeah, at the time when we announced the project, it was April 2016, and Stephen Hawking came from the announcement in New York City, and we didn't know that there is a planet in the habitable zone around Proxima Centauri. It's a dwarf star that is 12% the mass of the sun, and it has roughly half the surface temperature of the sun, so it emits mostly infrared light. And the habitable zone is actually 20 times closer to the star than the Earth is from the sun. And then a planet was discovered a few months later after the announcement, Proxima b, and that was a very pleasant surprise for us. So then we knew that we want to image that planet and see if there is life on it. The planet is so close to the star that it faces the star with the same side at all times. It's tidally locked. Just like the moon is showing us the same side all the time because it's tidally locked. There is this other side of the moon that we've never seen. So there is a permanent day side on Proxima b and a permanent night side. And my daughters argue that if we ever go there, we should build a house on the strip that separates these two sides, because then they can go to the porch and watch the sunset forever. The sun would never set there.
That makes some kind of sense, I guess, certainly to your daughters. What the Starchips? What was the idea of the Starchips? I was a little unclear on that.
Right. So we want to send some equipment, for example, a camera and a communication device on these light sails. So the chip is basically an element of the sail that contains those devices, and you can pack them into a few grams of material because we do it already in cell phones. And so that is actually the part that is relatively straightforward. We already have it. The challenging part is the laser and the sail and the communication, I would say.
Gotcha. Going back now to where we were a little bit backwards here, and going back towards Omula Mua and the explanations for Omula Mua, it's interesting to me that people would be so resistant of the concept that you had, that this could have been some space junk. It could have been a version of a Starshot initiative that somebody else did, because all the way back to 1977, we've been launching our own interstellar probes with Pioneers 10 and 11 and Voyager 1 and 2 and the New Horizons. And the golden records that we put on the Voyagers 1 and 2 that had signs of what we were and signs of our culture, the way we ate, the way we walked, the way we talked, whatever that could be put on those. It was the most creative and innovative and far-fetched thing I'd ever heard of. Carl Sagan said it is also the most hopeful thing human beings have ever done. To me, that says we've been doing this for a long time, and your suggestion is that this could have been something sent out by somebody else in the billions of years in the existence of the universe and in the billions of planets and places where there could be intelligent life. It seems strange to me that some of your colleagues have been able to imagine hydrogen dust bunnies, but they're not able to imagine that this could be something we're doing. That's our only example of what intelligent life does, is what we're doing. How is it so difficult for them? Can you help me understand that?
Yeah, I agree with you. And the point is, I would like to make 2 points. One, that our telescopes are not really trained to look for things moving very fast, like Starshot sails that move at a fifth of the speed of light. We are looking for objects that move roughly at the speed of comets or asteroids. So if there was a sail moving across the sky at a fifth of the speed of light, it would have been ignored by astronomers because they would think that it cannot be real. That's again the algorithm, the software that is being used is not looking for objects moving at that speed. It's looking for objects that move like rocks. So then when astronomers say, oh, Omula Mua didn't move much differently than a rock that we've seen, that's because the algorithms selecting objects in the sky are designed for that. And also there could be many more objects smaller than Omula Mua than Omula Mua size object. NASA never launched an object the size of a football field to space. We've never done that. So if we saw one Omula Mua, there might be hundreds of meter-sized objects, CubeSats, filling space that we don't recognize because they reflect much less sunlight. And obviously, we should check our mailbox to see if we have mail. You can't just say, no, I don't have mail, because some of this mail may be important. We may learn about civilizations far more advanced than we are. There might be a letter in the mail that says to us how to save ourselves, how to behave better so that we will maintain longevity. And it's important for us to recognize that, we are probably not the smartest kid on the block. Let's be modest and explore. And frankly, I'm very embarrassed by what we sent into space. So first of all, the golden record, was designed in, 4 decades ago. It's really embarrassing because since then our technologies developed so much, and if they were to look at that, they would say, okay, well, this is not a very advanced civilization. And a more embarrassing thing that we sent out than the golden record was what we put on the New Horizon. That was the last mission that we sent to exit the solar system. New Horizons carries a box that includes 30 grams of the ashes of Clyde Tombaugh, the scientist who discovered Pluto. New Horizons was supposed to explore Pluto, and it wanted to commemorate Clyde Tombaugh. Now, why is that embarrassing? Because what are ashes? Ashes are burnt up DNA. So we took the genetic information about a scientist that we wanted to commemorate. We destroyed all the information, and we put it in a box and sent it to space. Now, these ashes are no different than the ashes from a cigarette. They contain no information about Clyde Tombaugh. So if an extraterrestrial looks at the box, sees the ashes, that extraterrestrial would conclude immediately that we have very primitive rituals that make no sense whatsoever of destroying the information about a person we want to commemorate. How is that? How does that make sense? And it was sent, this box was sent by, NASA, a scientific organization. So I actually asked the principal investigator of New Horizons, Alan Stern, who is a member of the Galileo Project, who I respect a lot. I said to Alan, why would you send that? Why not a stem cell from the body of Clyde Tombaugh that carries the information about his genetic making so the extraterrestrials could reproduce him? And Alan Stern said, well, it would have been a bureaucratic nightmare to send any living cell or any biological sample on that spacecraft. So I said, okay, well, in that case, you should have sent the electronic information about his DNA, and that's it. That's much better than ashes. So I'm actually embarrassed by this so much that I suggested that we must launch a spacecraft that moves much faster than New Horizons so that it will overtake it. And by the time the extraterrestrials discover that we exist, they would get a good first impression. And in that, we will apologize for what comes next.
Okay. I like the concept of that. In your book, you say that some of the resistance to the search for extraterrestrial intelligence boils down to conservatism, which many scientists adopt in order to minimize the number of mistakes they make during their careers. Can you expand on that a bit and also tell us how you would avoid turning scientific consensus, we talked about this briefly, into self-fulfilling prophecy as opposed to actually helping the effort?
Well, it's quite clear for me from the experience that I had over the past few years that the current culture in academia is not healthy. It's not supporting innovation. The fact that the government is more open-minded than academia to this concept of having objects that were not human-made or are not produced by nature is an illustration of how conservative academia is. And, that's damaging for innovation because young people are afraid of speaking out. And, the most important way for us to learn something new is by cultivating a culture where people are not afraid to speak out. And, when I was in the military, I started in the paratroopers, and I remember a statement saying that sometimes a soldier needs to put his body on the barbed wire because that would allow other soldiers to pass through. And that's the way I feel. There are lots of young people that are afraid to speak out, and they tell me how excited they are about studying extraterrestrial technological relics. And I'm willing to suffer through the pain of people ridiculing the subject or saying bad things about me personally for no good reason. They just want to suppress any discussion on this. And I believe that eventually this subject should become part of the mainstream of science, because, it's not just this subject, but if you look in theoretical physics, people talk about the multiverse, people talk about extra dimensions, people talk about supersymmetry. These are ideas that were never demonstrated to be real. There are virtual realities, if you want. And why are they popular within the mainstream? Because they provide a sandbox for physicists to demonstrate that they are smart by doing intellectual gymnastics. Just like the question, how many angels can sit on the tip of a pin? That sounds like a fascinating question. Let's work out the math. And obviously there is no risk that we will be proven wrong, because nobody can make an experiment that will test how many angels can sit on the tip of a pin. So much of academic work is trying to demonstrate that you are smart, that you can do mathematical gymnastics, and so that you can get honors and awards. And it's more of a social activity to impress your peers. And part of that is, of course, demonstrating that you are an expert, and you can be an expert on a virtual reality. You can talk about extra dimensions, you can talk about the multiverse. These are things that we don't even have a chance of disproving during our lifetime, because there is no experiment testing them. Now, what's the problem with virtual realities? The problem is Ponzi schemes. If you think about Bernie Madoff, he had a beautiful virtual reality in which people will give him money and he will give them back more money in return, irrespective of what the stock market does. And again, just like we are at the center of the universe, that was a beautiful idea. Now, in his case, the demonstration that it was a beautiful idea was that people were willing to give him money, right? What else can be more powerful than people saying, that's such a beautiful idea that I'm willing to give you my money? That's a demonstration. So then, of course, the problem was that you can do an experimental test of this beautiful idea. That's the problem, because then they asked for the money back. That was the experiment. And he was put in jail. So how do you avoid Ponzi schemes? The way to avoid them is by following evidence, by following experiments. So the experiment will tell you whether it's a nitrogen iceberg, a hydrogen iceberg, or a dust bunny. If it's any of those, I would be very happy. We learned something new. I don't care, what it is. It's something new. Okay. Now, if on the other hand, if you say, I believe in the multiverse, and I don't need any evidence for that. To me, that's counter-scientific. And how can that be part of the mainstream? So there are some leading scientists who advocate the multiverse and at the same time ridicule a discussion on the search for extraterrestrial artifacts near Earth, or at the very least ridicule the possibility that Omula Mua might have been one of them. And I just find that completely inconsistent. Because if you look, for example, we don't know what most of the matter in the universe is. It's called dark matter for the lack of a better understanding. So we just say there is some matter out there whose nature is unclear. So for 40 years, we've been searching for specific types of dark matter, investing hundreds of millions of dollars. In fact, the Large Hadron Collider, which was a $10 billion endeavor, was looking for specific types of supersymmetric particles and couldn't find them. Okay, so that we know the dark matter is not of that type that was advocated for many decades since I started doing physics. And that was part of the mainstream. And people got honors and awards for working on supersymmetry. String theory was founded on that foundation, saying supersymmetry is part of superstring theory. And then it was not discovered, okay? And I say, okay, well, let's invest hundreds of millions of dollars, or, I'm not talking $10 billion. Let's search for equipment, because we sent out equipment, and we know that, other planets may have conditions similar to Earth. They may have had it 1 billion years ago. So why not just check, And why should that be ridiculed? That's less speculative, actually, and it has huge implications for the future of humanity. Whereas if we found that the dark matter is weakly interacting massive particles, it wouldn't change our lives. So I find that to be a cause that is worth putting, my body on the barbed wire for, because I think it has huge implications for humanity. It's being ridiculed for no good reason. It should be part of the mainstream of science, and it's not. So just the resistance to that. I worked on the dark matter and the nature of dark matter, made proposals for the nature for decades. And it was completely legitimate to suggest ideas that were not proven right yet, so that experiments can be designed to search for that. And then I come to the context of Omula Mua, and I do this exactly the same thing. I'm proposing a possible explanation, and people go after me like crazy. And I don't understand that.
I don't either. I found it very, very intriguing that we could do on the one hand this and on the one hand that, and they just didn't make any sense when you combine them together. Albert Einstein said that imagination is more important than knowledge. Knowledge is limited. Imagination encircles the world. When you talk to your students about the appropriate application of scientific method, and that's in essence what we're talking about here, do you preclude imagination or include imagination? You say, is it just the evidence, ma'am, or you say, no, you have to use your imagination to figure out how the evidence makes sense and to describe something you may have never seen before.
Right. So I do think that imagination is extremely important in motivating us looking for new evidence. Because if you have some anomalies, for example, and you don't have the imagination that will suggest what these anomalies might mean in terms of new physics, new understanding of reality, then you wouldn't collect the evidence necessary. If the caveman would look at the cell phone and say it must be a rock, then the caveman it will not be a learning experience. The caveman will not realize that he's holding a piece of equipment that was not manufactured by nature. And so imagination is extremely important. Now, the one issue I have is imagination should be constrained to be consistent with what we already know. So, for example, it should be consistent with the laws of physics, because we haven't seen a deviation from the laws of physics. So there are lots of people with imagination that write science fiction where the laws of physics are being violated. That bothers me. Okay, so the reason I became a physicist and I practice physics is because I say, it's just like the oath of medical doctors. I say, okay, we learned something over the past century about quantum mechanics, about physics. We know the laws of nature based on laboratory experiments. Until we find evidence for the contrary, let's adapt these laws, because in difference from the laws of society, that people violate all the time, they're put in jail, that's why we have the police. The laws of physics are not violated. They apply throughout the universe. Nothing can escape them. So, except if you go to virtual reality, you can avoid them. Okay? So you can put goggles of the metaverse and imagine things that violate the law. I don't want that. I want to live in the actual reality. And so I say, let's learn the laws of physics and have our imagination constrained by that. So it's not science fiction. It's science. So imagination is part of science, assuming the laws of physics and then imagining things that are allowed by the laws of physics. It's completely allowed that if we exist and send out equipment, that someone else exists on a planet like the Earth and send out equipment. That's not violating any laws of physics. It violates the imagination of the mainstream of astronomy. A lot of people in that mainstream, it violates their imagination, but it doesn't violate the laws of physics. So my point is, as long as you have imagination, that allows you to break new frontiers, to figure out something new about reality. And one of these new things, it may be that we are not the smartest kid on the block. And by the way, there might be a committee in the Milky Way galaxy trying to figure out if there is intelligence, in an intelligent civilization near the sun. And based on the behavior of humans so far, they might have decided not yet. Because even in academia, those humans are not open-minded to new evidence. They say, look, they laugh. Look, they saw something unusual. They don't even, they ridicule the subject. They keep thinking that everything is rocks. They are really primitive still. They send out a box containing, burnt up DNA of a person they want to commemorate. Look at what the culture they have at the moment.
It's wonderful that you're such a fan of Galileo, who said evidence doesn't care about approval, and neither do you, obviously, Avi. We're going to run out of time if we don't move along really quickly here. I just want to ask you a couple of a couple of quick questions about Galileo, and maybe one or two hypothetical questions if we have the time for it. And then I want to hit your Galileo project one more time. How do you respond to a critic who suggests that the Galileo project is too ambitious and unfocused and is likely to spend a lot of money and see nothing? I know what your answer is going to be.
Well, that person must not know what we are doing, because we have 6 subgroups within the Galileo project that meet for an hour each every week. And we purchased instruments that we will put together on the roof of the Harvard College Observatory. The project was established only 6 months ago, and we are in the process of writing 6 papers that detail what we are doing. And so that again shows you that it's very easy to be superficial, to just make statements without knowing what's going on. So that person should have asked someone within the Galileo project to figure out what's going on before making it. But of course, that someone doesn't want to look through the telescope in order to find whether the sun moves around the earth or the earth moves around the sun. It's exactly the same approach. Basically, that person wants the Galileo project not to succeed, wants to have this superficial view of the Galileo project, not to acknowledge but again, it will not change anything, because once we start assembling data and analyzing it and submitting it to peer-reviewed journals, then that person, that person would say, "Oh, of course they are doing some work, but this and that." And even if suppose we find something, that person would say, "Oh, there is nothing new about that, because people talked about equipment from other civilizations before." And then that person would say, "I actually talked about it." So, it always reminds me of a congressman that was for many years making negative statements about gay people. And then when that congressman ended his term, he came out with a statement that he's gay. Okay, so I wouldn't be surprised if a lot of the people that make negative statements without justification about what we are doing within the Galileo project are really intrigued by it and are really very excited about it, but just pretend so that others will not blame them for siding up with the narrative of seeking evidence.
So all of the evidence, everything that you find in the Galileo project, from the UPAs, I guess they're calling them now, and the work you're doing there, and all of this will become public information, right?
Right. It will be open and transparent. The analysis will be transparent, and anyone will be able to look at the data. So we are trying here to do something new that, in the past, there was the government data that was classified, most of it. And then there were people ridiculing, nobody looking seriously at this subject. So we are trying to break a new trajectory here. And, it reminds me of Robert Frost, who wrote the poem, The Road Not Taken, where there were 2 paths in the woods, and he took the one that was not taken, and that made all the difference for him. For me, the main difference is there might be low-hanging fruit in that path because nobody took it. And in that case, within a year or 2, the Galileo project may find something really extraordinary that is beyond a reasonable doubt. And I want to speak with that person that you spoke with and show that. And my guess is that person would simply say, "Well, a lot of people talked about it before, so it's not."
Yeah. Well, let me, we're going to run out of time, unfortunately, because I'd love to keep this conversation going. But let's jump to Omula Mua's wager, in which you suggest that we should bet that humanity is recently brushed with extraterrestrial technology. That is, that your theory is an appropriate one, and fundamentally shift what we seek and what we expect to find out in the universe. That goes right to the Galileo project. But you also say, live, you say, as if you know there is or has been intelligent life in the universe other than our own, and we will redefine some of the missions of humanity. Do you think that in your lifetime, this world will come to a place where the majority of people will take Omula Mua's wager, or they'll continue to be run by naysayers?
Yeah, well, first of all, I should say the reality that we live in is not a matter of popular vote. It's not like in politics. Galileo didn't need to be popular at his time in order for NASA to launch rockets based on the idea that the Earth moves around the sun today. Okay, so for me, what really matters is to have conclusive evidence that is obtained in the scientific method without prejudice by using the best instrumentation we have to collect the evidence. And of course, if we don't attempt to collect the evidence, if we ridicule any project that attempts to collect the evidence, we will never find it. So it's a circular argument, and that's what those naysayers are advocating for. They don't want to look for the evidence, just like the philosophers didn't want to look for the evidence through Galileo's telescope. Okay, but we will do it. I have the money. There are more than 100 scientists very excited about it, and we will do it. Now, the point is, once we get, let's say, a high resolution image or a clear evidence for something unusual that is not human made and not natural, okay, something that represents extraterrestrial equipment, for example, that has a label saying made on exoplanet Y, very far away, then that's it for me. I don't need to convince anyone. I will be happy at that, knowing that, and then let other people adapt to the circumstances. Now, eventually it will have a huge impact on everyone. Because if you think about it, just a couple of weeks ago, President Biden signed into law the defense budget, the defense bill. It was $768 billion dedicated to protecting the United States against adversaries, against other nations. Okay, if you think about it, it's just like a kid playing in the kindergarten with other kids, and trying to beat them, or so nations are competing with each other, are worried about each other. That's what we spend the money on. Okay, and the largest science project funded so far is $10 billion. It's the Large Hadron Collider or the James Webb Space Telescope, and that was constructed. These projects were constructed over several decades by multiple nations. So in 1 year, we're investing thousands of times more money than in those big science projects. And just imagine a situation where the Galileo Project finds a piece of equipment from an extraterrestrial civilization, okay? Then it's quite conceivable that the politicians will say, well, it's not a matter of national security, but it's a really important matter of international interest. And then imagine them saying, well, it's just like kids playing in the playground, and suddenly realizing, oh, wow, there is a city out there. There is something bigger than that, So you can imagine investing more than you invest in national security, more than $1 trillion a year. Now, that would be thousands of times more than science gets right now. So the question is what to do with it. So obviously, you can build bigger and better telescopes than the Galileo Project is doing to monitor the sky. You can also send probes that equipped with artificial intelligence into space that will explore our neighborhood. And we need to reorganize our society, humanity as a whole, because one thing I noticed throughout human history is that it's being shaped by a group of people trying to feel superior relative to other people. The best example is the Nazi regime. It triggered the death of 75 million people, which was 3% of the world population in 1940. That's 10 times more than the number of deaths triggered by COVID-19 so far. We've been talking about COVID-19 for 2 years now, but think about it. Just a group of people deciding to feel superior killed 10 times more people in 1940. So my point is, if we find a smarter kid on our block, it would make all of our differences as humans meaningless, and maybe bring us to the sense of modesty that we all need to have, and bring us to the sense that we should treat each other with respect as equal members of the human species. That's really a big lesson for us to learn. I see the source of all evil in human actions, all human actions, to be arrogance and the ego, the human ego, and that's true also of what we talked about before, trying to promote your image in academia, that's driven by ego, rather than, trying to think, oh, we are the most intelligent species that ever existed unless there is extraordinary evidence. I would argue the other way around. Let's assume that what we have here is nothing unusual as a starting point, and then search. And if we don't find anything, like dark matter searches for 40 years didn't find anything, then, in 40 years after investing billions of dollars, we would be at the same point as we are with dark matter searches right now. So that's part of the mainstream. This subject should be part of the mainstream out of a sense of modesty.
From your lips to God's ears, all of these things you've just been talking about are so important and so interesting. But unfortunately, we are out of time. You said one other thing that impressed me. You said, if I attract one child somewhere in the world into science as a result of my answering the demands of the media, I will be satisfied. I hope what your time spent here with us at the St. Helena Forum will do just that, and help in that effort in one small way at least.
Thank you so much. And I should say that the biggest thrill that I had from the publication of my book was that a woman from Africa said that after reading it, she was inspired to go into science. And, that was amazing to me. The other thing that happened was that the book got accolades and it was selected as bestseller. And my publicists asked me, are you going to celebrate tonight the success of the book? And I said, given all the heat that was generated by the publication of the book, the skin on my body turned into material that resembles titanium. So I don't get any pleasure nor pain from what other people think about me at this point.
Fantastic. Ari, you have been a total delight to talk to. I wish we had another hour that we could give to this subject, and hopefully one day we'll have a chance to get back together with you. You have truly been a delight, and I'm really grateful for the time you've spent with us. Thank you so much.
Thank you for inviting me. It was a great pleasure.
Thank you. Bye-bye.
And thank you all, wherever you may be in the world, for being with us today at the forum. If you'd like to learn more about the subject of today's presentation, you'll find related links on our website at shforum.org. To learn more about the Starshot initiative, go to breakthroughinitiatives, all one word, .org. And to learn more about the Galileo Project, go to projects.iq.harvard.edu. Dr. Loeb's best-selling book, Extraterrestrials, The First Signs of Intelligent Life Beyond Earth, is available at bookstores everywhere. We have several new and exciting presentations in the works that will air over the next couple of months. Follow our website for exact days and times, and I will look forward to seeing you all at the next St. Helena Forum for Innovation and Creativity. As we say goodbye, we'd like to thank the following people for their generosity in making the St. Helena Forum and its continuing programs possible.